So let's work on this trig identity. As you know, as we have mentioned many times in the past, they can be solved in multiple ways. I'm going to start with the left-hand side because that looks complicated enough to me. And the left-hand side is this. I'm going to do a little bit of copy pasting to save some time. So the left-hand side is this. Now, instead of 1, I can write this. I'm going to write this, and I'm going to tell you why I think it's a good choice. Okay, instead of 1, I can write 1 plus tan squared theta divided by 1 plus tan squared theta. Why do I care about 1 plus tan squared theta? It almost seems like I'm making it more complicated. Look, the reason I do care about that is because I want the denominators to be the same. Okay, that's why. Now the denominators are the same. What happens to the numerators? You can just add them. So on top, I can write 1 minus tan squared theta, and that's still there. And that looks pretty good to me because I can cancel this, and I will have 2 divided by 1 plus tan squared theta. And that's simpler, certainly. So I have 2 divided by 1 plus tan squared theta. Now, things are looking pretty good to me. Remember, 1 plus tan squared theta or tan squared theta plus 1 is equal to secant squared theta. Now I can write, let me take a new box. Now I can write 2 divided by secant squared theta instead of 1 plus tan squared theta. It's legit because I'm using the trig identity. 1 plus tan squared theta is equal to secant squared theta. Now, secant squared theta is simply 1 over cosine squared theta, and that's what I'm going to do. Now, I can flip and multiply, and what do I get? I get exactly what I was hoping to get, 2 times cosine squared theta. And that is the right-hand side. And I proved my trig identity. Right here. Done.